Hey guys, so we're going to now dive into example number 2. So here they tell us they give us the function that y is equal to the square root of x. And they want us to find the derivative of f of x when x is greater than 0. And we'll talk about a little bit more about why this is here later on, maybe towards the end of the problem here. But I guess first step is let's try and find the derivative of this function y equals the square root of x. And so I'm going to start by writing out the definition of the derivative formula. Now, we can write f prime, but here because we're working in terms of y equals, I'm just going to go ahead and write y prime. And again, there are different notations that you can use to write this out. So again, just pick the one that you're more comfortable with, but it's always wise to get used to all of them. So here I'm going to use y prime is equal to the limit as h approaches 0. And again, we have, let's see, f of x plus h minus f of x all over h. And if you've seen the previous video and you've seen the example to the previous video and you kind of understand what to do, I would recommend that this would be a good point to pause the video, finish this problem off, and see at the very end if you get the same answer that I'm about to get. Otherwise, just kind of watch with me and take some notes here. So let's see, it looks like we're going to have to do some work here. The first thing that we're going to want to find is f of x plus h. So I'm going to do that off to the side here. Alright, so I'm going to want to find f of x plus h. And what that means is I'm going to want to take this junk that we see here and substitute that into wherever we have an x value in the function. And so the only x value that's in our function is right there. So I'm taking the x that's up here and I'm replacing it with this x plus h. So it's going to look something like this. It's going to be the square root, and instead of x, again, we're changing that to x plus h. And now there's nothing for us to multiply out, there's nothing for us to do here. So it turns out that this right here is what we're after. So I'm going to put it in a box and save it away, or save it just for a moment because we're going to use it in just a second. The next thing that we're going to have to find is this negative f of x. Now notice that f of x is just the original function, which is this square root of x. Now, the negative of f of x means that we're going to have to multiply both sides by a -1, and so -1 times the function is just negative f of x, but a negative here is going to give us negative square root of x. And so here we have the second piece. So now we have this, we have that piece there. So now we can go ahead and put all this stuff together. All right, so let's see, let's try and do that. So we're going to have, let's see, y prime is equal to the limit as h approaches 0. And then we're going to just substitute everything that we found. So here f of x plus h was just this mess right here. So it's the square root of x plus h minus, right, square root of x, this part right here, square root of x. And then this is all divided by h. Now, we need to clean this limit up before we can actually evaluate it. Now, anytime we're dealing with square roots within a limit like this, it might be wise to multiply by the conjugate. So again, I'm going to go ahead and multiply the top and the bottom by the conjugate of the numerator, because the numerator is where I have the square roots. If the square root issue was in the denominator, then I'd be multiplying by the conjugate of the denominator. So here the conjugate is going to be the square root of x plus h and the square root of x. Again, nothing is changing. The only thing that changes is the sign in between these two terms. So instead of a negative, it becomes a positive. And whatever I do to the numerator, I have to also multiply it with the denominator. Or I have to do it to the denominator as well. So notice it's going to be the same exact thing. Now I'm going to go ahead and wrap some parentheses around this stuff because we're going to have to multiply this thing out. And we'll do it step by step here. So again, I'm going to drop down the y prime. We're going to have the limit as h approaches 0. And let's see what we get when we multiply all of this junk out. So here we're going to have the square root of x plus h times the square root of x plus h. Now, square root times a square root would mean that we're going to have a square root squared, because we have two of them. And that's going to cancel out, leaving us just with whatever's inside that square root, which is x plus h. That was a little weird for you to understand. Just think about it like this. We had the square root of x plus h times the square root of x plus h. It's really what we're doing. And then the square root of x plus h times this is really the square root of x plus h squared. Now, a square and a square root we know will undo each other, leaving us again with just that x plus h, which is what I have written right here. Now we're going to go ahead and multiply this junk right here. So we have the square root of x plus h times the square root of x. I'm just going to keep them separated like this. I'm going to write the square root of x plus h times the square root of x. I'm not going to really multiply those things out. Just going to kind of put them together. Then in the inside, I'm going to go ahead and multiply these out. So here I have a negative square root of x times a square root of x plus h. Very similar to this, the only difference is that now it's a negative. So I'm going to write the square root of x plus h first, and then times the square root of x. Okay, so I'm not really going to focus on the multiplication here. I'm just going to leave them like that because I noticed that I'm going to have a positive and a negative, and they're both going to cancel out. And then finally, we have negative square root of x times square root of x. So that's going to be a negative because a negative times a positive is a negative. And again, if we apply the same logic, the square root of x times the square root of x, okay, well that's just the square root of x squared. And again, that cancels out, leaving us with just x there. And again, this is all divided by h. Now, hopefully that wasn't too bad. Or I'm sorry, actually it's not just divided by h, right? Because we also have this here in the numerator. Now what I'm going to go ahead and do is I'm not going to multiply I'm sorry, I said numerator, I meant denominator here. I'm not going to multiply this out. All I'm going to do is just bring the h down, and I'm going to bring this stuff down here as well. So this is going to stay like this in parentheses. I'm not really going to multiply it or mess with it. Okay, so sorry about that. Totally forgot about that. Now we're going to go ahead and see if anything in the numerator cancels. So in the numerator, I noticed, let's see, I have an x, and I also have a minus x sitting there. I have this positive square root of x plus h and square root of x minus a square root of x plus h and a square root of x. So I know that these guys are going to cancel out. So that's gone, and this is gone. And so it looks like all that's left, let me rewrite this here. So we're going to have y prime is equal to the limit as h approaches 0. And let's see, we're going to have, in the numerator, it looks like the only thing that's left is just this h. In the denominator, we're going to have this h again. But we have this square root stuff that we didn't multiply out. All right. Now let's look at the numerator and denominator and ask ourselves if there's anything that we can cancel out. Well, it turns out that we can divide this out. It turns into a 1, right? So h divided by h is just 1. So this is going to turn into, let's see, y prime is equal to the limit as h approaches 0. And all that's left now in the numerator is 1. And the denominator, we just have left the x, or the square root of x plus h, plus the square root of x. And now we can evaluate the limit. And so now if I plug in 0 as h goes to 0 and I plug in 0 for h, we're going to end up getting, let's see, 1 over the square root of x plus 0 plus the square root of x. Now remember, we're plugging 0 into h, not x. That's one common mistake that I've seen students make in the past. So here if we just evaluate this, we're going to have, let's see, 1 divided by x plus 0 is just x, so this is going to be the square root of x plus the square root of x. And then the numerator is going to stay at 1, but the denominator, we're going to ask ourselves, well, how many square roots of x's do we have? Well, that's 2 square roots of x, so it's going to be 1 over 2 square root of x. And so there we have it. Our derivative, y prime, is equal to 1 over 2 square root of x. And this right here is the answer. This is our derivative as a function of x. Now if we look at the question, this was the answer to part A. So this is the answer to part A. If I go back up here, part A wanted us to find the derivative of f of x for x greater than 0. Now, the reason we included this part for x greater than 0 is because notice here that we have a square root as our derivative, and x cannot be negative because the square root of a negative number is imaginary. It gives us complex numbers. And since we're only working with real numbers here, that is why we have that restriction, or that's why we had to say for x greater than 0. Also notice that we're not saying that x equals 0, because if x is 0, then we're going to have the square root of 0, which is 0, and we cannot be dividing by 0 here. And that should explain, that should now hopefully make this statement right here make a little bit more sense on why it's written. Look at part B, the question of part B. How fast is y changing at x equals 4? One thing that I didn't mention is that the derivative is really, it tells us the slope, right? And the slope is like the average rate of change. But by us finding the limit and making this a limit problem, we can now find what's called the instantaneous rate of change. Like, how is it changing at a moment in time, at a specific moment in time? And so when I ask you a question like how fast is y changing at x equals 4, all we have to do is go to our derivative function, and now we can just simply plug in 4, and that'll tell us how fast a particle is changing or how fast something is moving at a particular moment in time. So to answer the question for part B, so at x equals 4, let's see, y prime is equal to 1 over 2 square root of 4, because we're going to substitute 4 now. And the square root of 4 is 2, so we're going to end up with 2 times 2 in the denominator, and we end up with 1/4. So if this was an application problem of some type and we had some units, we could say, oh, you know, at 4 seconds, the particle is moving at 1/4 meter per second, or something like that if we had units involved. But here it's just a straightforward calculation. So the answer to part B is 1/4. And so another way to think about this is that the slope at x equals 4 is 1/4. The rate at which the graph is changing at x equals 4 is 1/4. That's another way to think about this answer here. So in the next video, we'll answer the question to part C, which is finding the tangent line.